Welcome back, dear students. Last class we have learnt about Newton's first law of motion. The first law of motion indicates that when an unbalanced external force acts on an object, gets an acceleration. But we need to understand that how the acceleration of an object depends on the force applied to it and how we can measure force. Let us observe these examples.
That table tennis ball hit a player, but the player is not badly hurt. However, cricketers wear special gear to protect themselves from injury from fast-moving cricket balls. Why? What is the difference between the two balls? The cricket ball is heavier than the tennis ball. We can conclude that the impact of an object is dependent on the mass of that object. On the other hand, a bullet is much smaller than the cricket ball. But it can kill a person when fired from a gun. How can such a small bullet be so lethal? Because it is traveling with great velocity towards its target. These observations suggest that the impact produced by objects depends on their mass and velocity.
From these examples, we understood that the impact produced by the objects depends on their mass and velocity. These observations used by Newton to introduce new property called momentum. The momentum of an object is defined as the product of its mass m and its velocity v, that is, p equals to m into v. The SI unit of momentum is kg meter per second. The momentum is vector quantity. We know that unbalanced force brings about a change in the velocity of the object. Momentum is product of mass and velocity. Therefore, unbalanced force also produces a change of momentum. Let us watch these examples.
The battery of your dad's car has died. You and your brother are pushing the car to get it started. The car needs a velocity of 1 meter per second to get it started. You and your brother push. The car barely moves. You keep pushing and slowly the car starts moving and gaining speed. You keep pushing till it starts. As you can see, the time over which the change of momentum takes place also impacts force on an object.
The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now we will see mathematical formulation of second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F throughout the time t. Therefore, the initial momentum is P1 equals to m into u. The final momentum is P2 equals to m into v. The change in momentum equals to P2 minus P1, that is mv minus mu. If you take m common, we will get m into v minus u. Therefore, the rate of change of momentum equals to m into v minus u divided by t. According to the second law of motion, applied force is proportional to rate of change of momentum. Therefore, force is proportional to m into v minus u by t. We know that acceleration is rate of change of velocity, that is a equals to v minus u by t. So in the place of v minus u by t, we substitute a. Therefore, we will get f proportional to m into a. Let us remove the proportionality and introduce a constant k. K is a constant of proportionality. Therefore, force F equals to K into M into A. Now we will see unit of force. Force F equals to K into M into A, where K equals to 1, then equation becomes force equals to mass into acceleration. Unit of mass is kg and unit of acceleration is meter per second square. Therefore, unit of force is kg into meter per second square. Whole term is called Newton, or it is represented by capital letter N. Therefore, the unit of force is Newton. Let us define what is 1 Newton. 1 Newton is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. That is, 1 Newton equals to 1 kg into 1 meter per second square. The second law of motion is often seen in action in our everyday life. While catching a fast moving cricket ball, a fielder pulls his hands backwards with the moving ball. The fielder increases the time during which the high velocity of the moving ball decreases to zero. If the ball is stopped suddenly, then its high velocity decreases to zero in a very short interval of time and the ball hits the hand. Now, let us see how the mathematical expression of second law is helpful to calculate first law of motion. From the second law of motion, we know that force equals to mass into acceleration. We know that acceleration A equals to rate of change of velocity, that is v minus u by t. Let us substitute the value of A. Therefore, F equals to m into v minus u by t. On rearranging the equation, we get F into t equals to m into v minus u. When F equals to 0, we will get v equals to u. This means that the object will continue moving with uniform velocity u throughout the time t. If u equal to 0, then v will be 0. That is, the object will remain at rest. Thank you. We'll continue in the next class.